scale drawings. So the idea behind scale drawings is that you use as a form of a proportion, right? So we're still having two fractions equal to each other, two ratios, two proportion, or is a proportion. So we're doing something today called indirect. MEASUREMENT. Indirect measurement. Meaning it's not a direct measurement. You are not taking a giant tape measure and measuring something. You're using something else to help you measure. So this is used to find distances that are difficult to measure directly. Indirect measurement is used to find distances, measurements, that are difficult to measure directly. Right? It's more common a long time ago, before all of our modern technologies, right? You know, if you wanted to know how tall a tree was, but there was no way for you to, figure it out, climb to the very, very tippy top and measure it, you could use something called indirect measurement. The key is that we want to draw a picture. Whether it's a mental picture or a physical picture, it is very helpful to have a visual of what it looks like. These are famous math problems. All right, you go home, you talk about what you did in pre-algebra class. You talk about indirect measurement. Your parents say, "What is that?" And you explain the type of problems, they'll remember doing them. Right? They stick in your memory. They're about trees and flagpoles and mailboxes. Right? They don't vary very much. There's not a lot of creativity in these types of problems. So let's just start right off with an example. Yes, you need to write the word problem. So a tree casts a shadow that is 10 feet. Right? And a shadow is pretty easy to measure because it's just on the ground, right? I don't have to climb the tree to figure out how tall it is. A tree casts a shadow that is 10 feet. A 5-foot tall woman casts a 4-foot shadow. Luis, do you have a pass?
No, I was
Right, so a tree casts a shadow that's 10 feet tall. A 5-foot woman casts a 4-foot shadow. How tall is the tree? So, we're going to draw a picture. I've got a tree. And this tree, I know that the shadow is 10 feet. Tanner, you need to face all the way to the front, please. Then I've got a woman. And I know that this woman is 5 feet tall. And what else do I know about this woman? She has a shadow that's 4 feet. Make that a little longer. An indirect measurement tells us if we know two of the same things, if I know both the shadows and one of the height, I can figure out the other height. So I want to know how tall is the tree. I could put a question mark here, but since we are going to be algebra students, we don't want to put a question mark. We want to put the variable x. He had to pick one class from yesterday. So, quick. All right, how do you think we're going to set this up? Paige? Okay, so we're going to make a proportion. You told me that 5 feet tall gives us a 4-foot shadow. Right? And that's equal to 5 is how tall, so we have to start with how tall. X over 4 is my shadow. 10 is my shadow. So it's really helpful, you guys, to put labels. On top, I decided to put how tall something is. 5. X. Then I decided to have my shadows be my denominator. 4 and 10. Is this common sense? What do you do to 4 to make 10? Is there a common sense answer? No. So since it's not common sense, since I can't automatically see the pattern, I'm going to have to use cross products. What's 4 times x? Equals, what's 5 times 10? Divide by 4. What is it? Feet. What's 12.5 feet?
The height of
The tree is 12.5 feet tall. So this is indirect measurement. Lots of times it's going to say a flagpole is your first picture and a mailbox is your second picture. Or a giraffe and a person. Indirect measurement. If you know two of the same thing and one of the other, you can find the missing side. So that goes into scale drawings. And scale drawings are enlarged. Like in science class, a picture of a cell is a scale drawing. It's enlarged, right? It's too small for us to see, so we have to make it bigger. Or it can be reduced. Scale drawings that are reduced are really popular in social studies. Maps, right? I mean, when you look in your Kansas journeys, your Kansas history book, is there really a map the size of the state of Kansas? Right, it's gigantic. It wouldn't fit in a book, so we have to scale draw it. We have to reduce it. It's not somebody just draws a picture of the state of Kansas and calls it good. A true scale drawing is done using math. So it is an enlarged or reduced drawing similar to an actual object or place. Right, and we talked about similar figures yesterday. Similar figures have the same angle measurements, and they're proportional. It's not like I can't just draw two similar shapes and say that I did it. I'd have to mathematically draw it, or I'd have to put labels on it that show you that they are similar. Yeah, it's dilating. You're finding what you're dilating by. So let's do an example of a scale drawing. Scale drawings are sometimes easier just because it's less information. So the scale on a map is 1 inch is 4 miles. One inch represents 4 miles. And I understand maps, really the only place you use them is in school. You no longer have to worry about getting out a map and reading it while you're driving somewhere, right? That's done by your phones. But a long time ago, we used to have to carry maps around with us. You better hope that the internet never stops. What is the actual distance if it measures 2.4 inches? And I really like these problems because they're pretty easy because we've always practiced, like up here, we had to make sure that the tall and the tall measurement were both on the numerator, and the shadow were both in the denominator. Well, here, I want my same labels in the numerator and my same labels in the denominator. So my first 1 inch represents 4 miles. And what's my other piece of information? .4 what? Inches. So is that going to go in my numerator or my denominator? Numerator. Do I know my other denominator? So what could I put? Now, people are going to argue. Yes, it's common sense. No, it's not. I can take both ways. What do you do to 1 to make it 2.4? Multiply by 2.4. So 4 times 2.4 will give me x. If you don't see that right away, could you do cross products? Yes. X equals what? 9.6 what? Miles. If you look at a map and it's 2.4 inches long, so that's about what? There's an inch, there's an inch, and half an inch. So this long really represents 9.6 miles.